dsgn380. Today we're going to be trying to model a stub shaft. I'm not going to get into this but too much. This is not the first try here. I'm going to reuse this part. The goal here is to use McMaster car as much as we can. I'm just going to make a new file so you can see kind of where we're going perhaps. If you want to pick up this name, just open this up, click it once, and we'll call this 2. The point of this is to try and see how the shaft is shaped by the hub, in this case a sprocket. I'll just close this, we won't need to see this again. I'm going to initially get right at it and do a search for that part number on McMaster. Let's have a look here. I have this opened as well on a browser window, so we can just download this and then have a look at it later. So let's place it as a step. Go from there. So correct. There it is. I'm gonna kind of get it into place first, so just usually orient it correctly. I want this shaft, the stub shaft, just meaning we're going to do a truncated, like non-feasible shaft, just to show how the shaft is shaped. I'd like to have the small end pointing left. We're going to end up with a shoulder of some sort behind on this side. Let's place it first. Right now you can see it's locked because it naturally comes in locked. You can unlock it, unground, draggable. The move command is good, and we're going to go for point-to-point. Component, not the bodies within the component, but the whole component. If you want to check this, you can keep an eye on the origin, should move with it. So I'm not just moving the body within the component, but the whole component. Origin point, first we have to select what we want. Origin is where we're coming from, the center of that edge to the origin. So it should give us something. Just going to show my origin so I can pick it. There's my second point. And if you hold down controller, in this case command for the Mac, it'll preview on and off. You should see it now aligned. Both origins are aligned, although the origin for the component is actually right through the middle of the sprocket. Say OK and capture the position. So you might get a feature here. That's okay. Today is not going to be all about how to use less features. It's going to be how to get it done. So that's our beginning. It's not draggable. Oh, it is. Good Lord. Let's lock that, or ground it. Sorry. And now it's going to ask, do you want to move to the... This is what I was waiting for. It didn't show up. Update initial position. You got her. So there's our position. What's our history showing? Well, we might not actually even need that. Do we need it at all? Let's try deleting it. Well, everyone's good. So we had some kind of transitory positioning there. That's fine. We deleted it. Looking good. It's not draggable. Everyone's right. Now we have a component already. What's going on with that part? So let's have a look here. This is the part that we just downloaded. Sprocket type standard. It's metric. So ISO chain, which is metric. The pitch is right there. Now, what's going on here? Turns out this is machinable. Right now it comes with a diameter 12. It can go up to 32. We're going to go to 30, just to make a point here. And the usual stuff. So I'm in the US, and it turns out the standards is median R for the chain. So it's the sprocket itself, the teeth. So also in here, if we look at this, machinable up to 32. So we'll go to 30. So let's edit this guy. So we'll activate that. Nothing else there, so there's ghosted out nothing. And there's a good option here, which is just press pull. If we leave it at auto, see what it does. And it gives us a dimension 6. Well, let's type in 30. Oh, hold on. That's not right. It's the radius. 30 divided by 2. Let's make sure our document's sitting at millimeters. There we go. Sprite. And everything's looking good except for this probably needs a chamfer. Click that face first, search for chamfer, shortcut chamfer, sorry. And right now I'm going to give it a fairly small, say 0.4. It is a hub, so we probably want it to be a little bigger. How about 1.4? 1.6? Or even 2, right? So we can see how it goes. Right, so let's try 2 for now. It's quite large. Might be okay. Say okay. We can always change it later. Now, apart from, we're eventually going to place a key here. So apart from the key slot in the hub, we're ready to go. We're also going to keep an eye on the standards and all the rest. So the plan here is model the shaft, put in the key, and then add a ring at the end to hold it in place axially. That's the plan. So off we go. This time, instead of just modeling a body, I am going to try going to model a component. Some options here. Type is standard. So you can see that whole thing. I want to put my component internal. You can create an external version. It'll save it next to it, which is fine. I'm just going to call this stub shaft. But for us here, we're going to have it internal. And I want to activate it. So it'll ghost out this guy. I'm going to do a sketch. And you'll notice, because I have a new component, I can actually use the origin here of it. So I'm going to use its origin in case we move it. That's going to be the ZY or YZ. If we press slice here, it'll remove the occluding material. Nice. So let's have a go here. I'm going to go ahead here and use a intersect projection and just use the whole chamfer actually. Say okay. Be a little careful here. If I hide our hub, you'll notice these lines are actually solid. They might contribute geometry accidentally. I'm going to select them all and press X to make some construction. Nice. So next, let's do our stub shaft. Now, simple shape really. Like we just basically have an L shape. Just map it in, nice and loose. Line it up without a constraint. Try and get it horizontal, or we're using perpendicular here. We've got one horizontal, that's fine. Escape once out of that tool. I want to connect what will be our center line to the origin and turn it into a center line if I can select it. There we go. Coincident. Anyone will work. Just using these two backs. And then we do have to dimension something. I'm going to start with, say, 10 sticking out one side. And maybe 10 on the back. Again, trying to make sure I don't accidentally dimension to someone that's from another component. Now let's make this 10 as well. This is arbitrary. So there's more coming out here, but we won't see that. Now let's turn on the component again. Oh, let's turn on the component again. I press escape there. I want to be obviously not below here, so I have to be above. But what's a good number? One approach to doing this, which is kind of seems convoluted, but actually works nicely. We can just, whatever it's at, escape once out of the tool, toggle driven, pull it around. You get a feedback of where you're at. So 35 is really borderline. And if we want to go, say, 5 at a time, maybe 40, it looks okay. So then right click on it. Oh. Escape out of tools. Oh. Toggle driving. Type in 40. There we go. Is our sketch coming into control? Yes. Let's keep an eye on that. We're going to need a chamfer probably at the end of this. So let's add another line. And I'll put this in the sketch. You could also use a chamfer feature, but that's fine for us right now. And I'll make it say 2 to match our hub for now. We're going to come back into the sketch later and draw a ring groove, but that's it for now. And let's make sure it works by, oh, not that. Axis, pick the center line. Looks good. Oh, you can change it to full here. So it's a new body within our component. There we go. So everyone's looking fine there. Keeps us open. And we'll actually show dimensions so we can see what's going on. So if we want to change this later, we can. So if we hide it though, it hides. Perfect. There we go. Let's go back up to the top and have a look. It's quite a big chamfer, that. We'll see how it goes. Keeping an eye on it. Everyone's looking okay. While we're in the stub shaft, we should probably have a fillet in there. Again, if you're trying to get in here, sometimes it picks strangely. You can X out that row, hide the other stuff, and then just make sure you're getting the right one. Let's call this 2. And I would like to actually keep an eye on things better than just trying to guess. So let's also have an inspect section analysis through the YZ of the assembly. What we did is just a little bit dangerous. Right, we have a fillet that is actually the same size as our chamfer. So let's fix that while we're at it. Oh, let's fix that. Edit feature. Will it go in for us properly? There it is. Say 1.5. And that's strange, about 1.6 for now. A little bit of clearance, safer, but it's quite a big chamfer. A little worried about that. Keep on going. Now, next thing is a key. We have standards here. Gonna show the standard at first. There's a standard called dsgn380. This is just lifted from Ganter, who's a supplier. They show how to order all this sort of stuff, but this is the standard chart for shafts. They go up to 44. There's bigger ones, of course, but for us this is fine because we are at 30. Now, which one is it? Is it 22 to 30 or 30 to 38? So if we have a look, say, at another standard, the old guy, this is the SME. You won't be able to see top and bottom, but I've obviously looked before. Here's the chart, and they've got over and including over to include. So if you've got a shaft 1 1/4, it's this row, not the next row. So we're going to do the same. So let's go up to including. So for us, we have a 30, so we're at this row, which strangely, interestingly, is not square. 8 by 7. Now what's the 8 and what's the 7? And you can see why we often pick square keys. Well, 8 is B here, which is the width-ish across the end. L is the full length, including these arcs. So the rounds are included in the length. B is across the round. It's more or less the diameter of the round. Let's keep that in mind. See if we can get that. DIN 6885. So we'll use McMaster again. Key. Let's make this a little bigger. Again, if the browser gets in the way, you can close it down. Machine keys. Rounded. Metric. Width. That's that 8, right? 8. 8. that's the correct row. 22 to 30, 8 by 7. So width is 8. Height is 7. That's all we've got. Oversized versus undersized. Undersized is standardized. You can see these here. Undersized is DIN 6885. 6885. That's the right standard. So let's stick to a standardized part. Basically, undersized lets you pull it out easily. And oversized, you often you will kind of force this into the shaft, key seat, so it doesn't come out. Kind of a semi-permanent thing. For us, let's not do that. Let's stick to the standard. The cost goes up a little bit as well, but for us, we're looking at about $1 and a bit US. But how long? Let's close that. Now, it has to be completely under the hub, because we are going to put a ring groove in here to hold it axially, the hub that is. So we can't protrude out, and ideally, probably, you don't want it sticking out of the chamfer. And right now our chamfer, which is maybe a little unrealistic, is quite big. Let's have a look at our sketch. So turn on our sketch. We can maybe do a measurement here, can we? Oh, we can, nice. 31. Keep that in mind, 31 millimeters. So we're going to do this again, 8 by 7. Let's place it. So we've done this before. Do it again. Practice. Key. Metric. Width is 8. Now we've got rounded. Well, we didn't pick yet, so let's go rounded. Anything else we can choose here? It's not bad. Length is all we've really got left here. You can see it's 7 by 8. 7's our height, we hope. Let's check when we get there, but it is standardized, so it should be okay. We had 31 millimeters or so. Should leave at least 2 or 3 millimeters on each side. Go for 25. Undersized. It's about an inch. Let's do that. Let's have a look at the product detail. Tell us anything about placing it in the shaft? Actually, no. It just gives us a nice reassurance that we're getting the right part. It's 8 across, 7 high with tolerances. How big it is on your finger. But this is not going to give as much for the shaft other than the size of the guy. So let's just place it and then try and figure out how we do what we do with it then. Let's have a look at the right side. I'm just going to rotate it into place-ish. This pad will let me stretch it, move it around in 2D. It's going to be kind of in the middle. It's getting a little close to the top of the hub, but not too bad. So we're going to talk about this in a second here. And I'm just trying to drag it more or less into place. We've got lots of room around there. Looks good. So if our giant chamfer is okay, we're okay here. Say okay. And deground it? No, let's leave it. It'll place. It'll create its own components. That's what the holdup was there. And we're kind of there, but where is the right position for it? So this is problematic. Like, how do we go at this? My usual tendency is to model the key way and the key slot in the hub first, and then place the key into it. So let's do that. We're going to use the standards. There's our standard. This is just about the key shape and size. What about the hub? Well, of course, there's more to the standard. And one of the reasons we're doing this video with this DIN standard is there's 2 types. There's a low type. Where the hub slot is actually quite small. You can see T2 there, smallish. And the type 1, the high type, is taller. So That's kind of interesting. Let's keep that in mind. So we're going to go ahead here and try and model this. And again, they show us here a little bit more as well. So the DIN 6885-1 versus the DIN 6885-2. You can see that the 2 is lower. This is the low type, which matches up to what we're seeing above. So that's okay. So let's figure out what's going on here. We've got two options, so let's try and have a look at them both at once. What's D? D is the shaft, 30. Now B, what is that? Oh, that's this. So we're looking at this quite carefully here. So it looks like we need to start a sketch and use this to dimension it. Let's do that. Okay, so you can actually pull back and work inside the shaft component here. So I've got this fillet. It doesn't matter, we can do this after. I've also got a sketch here that's driving the shaft. Let's actually put the sketch for the key right after that. Hide that. And we'll insert a new sketch. We'll put it on this plane here. So it'll poke up. Search for slot. I'm after an overall slot because that's how I'm measuring the key. And what's going on? Can't snap. There it is. Snap in there. So to make a point though, I'm just going to draw it or sketch it like so. And get it into position as we do. So I'm going to add another construction line and make that, oh, not that way, horizontal. I was too close to the other direction. This can jump around a little bit. And so this time, get it right. There we go. Now, got the length of our hub here. So we can maybe use that in a second here, but let's get the length right. So our length is, well, which one did we want? We picked 25. Let's finish the sketch and make sure. Go up to the outside. So we'll do a measurement. Keep in mind it's 8. So 17 plus 8. I'm just picking the straight length is, what's that? 25. So let's go back. Our sketch is in the right spot now. Although, hold on, we put it at the top level. Is that a big deal? Maybe not, maybe yes, maybe no. It gives us some chance to actually cut some parts. So let's keep it at that level. So this is actually going to be, you'll notice where the sketch is right up here. Or do we want it inside the stub shaft? Maybe we can just pull it in. Oh, nice. Notice where it is now. So notice where you had to pull it. I'll do that again. We want to pull this sketch into the stub shaft because we put it accidentally at the top level. Let's grab it. Don't just, you have to, if you put it into the sketch, it does work. Another way, maybe we can just put it here. It doesn't work if we just drag it in there. So you have to put it in the sketches, a folder. And I'm going to give these two names so we know which one's which. This is shaft profile. This is Keyway profile. Nice. So far they're unconnected. We're just about to connect them up. So we will, this history order will be fixed in a second here. Let's pull back by just editing the sketch. I'd like this to be centered. So how do I do that? Well, kind of fiddly. Well, not too bad. I want to project some projections. Can I project that guy and that guy? Yeah, maybe, but these will move. So let's go for the more stationary versions. These two guys. Notice they project down. Oh, that one's at the origin though. Let's undo. Don't need to do extra because don't want overlapping places all over the origin. So let's project one more time, just the one we need. There it is. There's various ways to show this. I can do a line and pick the midpoint. Another obvious way, I think, which is kind of a good way, is to put the center of the circle on the line, snap it to both, make it construction. Make it construction. And you're thinking right now, why would you do that? Oh, why would you do that? Why would you do this? I'm trying to show where things are, and I want the midpoint of this line to be on that circle. So I'm just kind of trying to show where it is. Strange? Yes. So we need a midpoint on this line. Point. This is just point. One way to do this. So let's try and figure where the midpoint is. There it is. And I want it to be coincident with the middle of the circle. It's positioned, but it's not, doesn't have the side hit. So dimension 8. And now we're fully defined. Now, keep a note of this 25. We're going to have to change this because we're going to over control the key a little bit too much. We're going to end up changing this. So, but nonetheless, finish the sketch. I'm going to hide essentially my key for a moment. I don't want to cut it or anything, so I'm just going to pull the history back. I want the key up where it was. Let's have a look at the standard. We have a choice here. Low type, high type. This one is probably more realistic. Let's try this one and see how it goes. So this one is in the middle. Again, I looked this up as best I can. We're going to try doing a geometric construction, and then we will go ahead here and check that things are working out. So what we need here is the height, and see where we end up here with T3. So there's all this sort of problem here. It's up to us how we do this. We can either just go straight with T3. Let's do that actually. We'll leave the construction for a future video. T3 is the actual easy to measure for a machinist diameter. Oh, sorry, including the diameter minus half the height of the key T3. So T3 is what? Oh, right, D minus T4. T4 is that. So where are we here? 30, 26. Copy that. Let's go back to Fusion. Extrude. It's not quite what we want, obviously. So this is actually has to be changed to offset. Now what is the offset? Is it what we just got, 26? Oh no, that's not right. So our diameter is 30, our radius is 15. So what are we doing here? How do we do this in math land? 26, diameter is D minus T4. T4, where's T4? Right, so we're all 4, obviously. So maybe we could do the radius minus 4. That would make sense. So 15 minus 4. There we go. And it goes, well, all the way through everything, I think, for now. This is movable. So let's turn off our analysis and have a look at how we might place this. Let's place J, joint, put it in the middle. Oh, nice. And the sketches are in the way, if we can hide them if we want, in the middle. We can move this angle, but it's looking good right now. Say okay. It's really tight. If we look at our analysis, that's kind of crazy talk. So we do need to lengthen this out. Orlov changes, has a few guides. Let's have a look at our Keyway profile, show dimensions. If we just add a little bit to this 25.2. 25.4, like whatever we would like. I'm going to go with 25.4. This is better. Now, previous years I've made videos like this. We tried to put in some machine tip, tool bit tip fillets. Let's leave that. The standard takes that into account, but we will have fillets here. Fusion has a hard time with quite large parts with very minute magnitude different fillet, so we're just going to skip that. But one thing that we're going to run into here is, oh, hold on, that doesn't look right. Right, we didn't cut the sprocket with our cut. So there's a temptation here to just do it again, but what we can do is actually just modify that cut extrude. So right now it's going through all, which is all of them. So if we turn that on now, because we did it before it was hidden, so it's not part of the cut, but now we want to go through it, but not all the way. So maybe our standard can help. We're using the high type. So T1. So it's radius plus T1-ish in a way. So T1, we've got this. So let's see here. So T1 is diameter plus that guy. So T1, 33.3. So essentially 3.3 plus on the radius. So our distance is, now it's from, because if we do this wrong, say we say, okay, well, it's 15 plus 3.3. Well, that's not right. So what is it? So let's see here. So we've got 26 and T2 or T3. That's where we're at here. Hold on, what are we trying to get here? T1 is 33.3. So it's, oh, maybe we could just do 33.3 minus 26. 33.3 minus 26. Turns out our cut is 7.3. You can see it right here. So say okay to that. And notice what we have. This is good. We've got our key sitting in there, nicely spread, gapped on the top, which is what most standards ask for. It's hard to see on this one, but if we go back to our ASME standard, oh, crazy, we can see, where are we here? Sorry, trying to find the image. Then we have a gap above. Now this is showing, this is old school, it's also imperial, but there's a small gap here for the machining tool. Oh, sorry, fillet. There's a small fillet here for the machining tip, and the key tends to sit right inside. Once the key's under load, it's just being crushed between the two opposing faces. So there's really only two opposing touches. There's not much effect by the bottom or top, if it touches at all. So for us, we can leave it touching, but we've got a bit of gap here. If we want to know what the gap is exactly, I think we already know, but let's have a look. .3. So that's probably enough to deal with any radius issues or anything like this. That's where we're going to leave that. That's all good, except for one small problem. We can't load this, we can't assemble this because we've trapped the key in between the shaft and the hub. What do we do? Let's have a look just at this. Actually, let's even just isolate it right now. Eventually, don't crash. There we go. There's our problem. What if we just do this? Like, does that work? No. So we might actually have to draw a sketch here. So that's fine. So let's do a sketch on this guy. So we're active. Sketch. Let's put, well, we'll use its. Is this the right one? Yeah, that's the one that goes right through the sprocket teeth. I'm going to project. Well, what? Should be able to just project any of these. Maybe if I just project this whole face onto the sketch. Or the other one, since it's right there. Say OK. Now, we've got this strange shape. It's probably going to be okay, but to be kosher, let's add an extra line. Just make it rectangular. And make that one a construction, so then our region is that rectangle. Now extrude. Both ways, so there's two sides. All. Make sure it didn't cut everything else. It shouldn't, because everything else is hidden. Let's unisolate. And go to the top level. Nice. Let's get finished here. This is going to be quite long. Doing okay. We still got some questions about this chamfer. And the question is going to be answered when we do this next part, which is the ring, sorry. So I'm going to put the ring groove into this first sketch. So edit sketch, the very first sketch. I'm going to make it quite giant for now. We want the ring up against the hub. It won't sit there exactly. One approach to this is just line up the back of the groove. It'll give it a little tiny bit of leeway to move around. It's kind of up to you, and depends on where you work. I've been told from time to time that we should always give it a little tiny bit of leeway. It's like a fraction of a millimeter. So we'll just keep an eye on that. This is way too big, of course, but we want to use the ring itself to do our work, finish the sketch. This feature has to be adjusted though, edit feature. I like to just delete the entire profile and repick the inside. Gives me what I want. That groove is way too big, but it's okay for now. Next, let's place the ring. Ring. A retaining ring. This is internal, we're external, we're metric. It's driven by our diameter again, no surprise there. Let's do a filter. There's lots of these, 30. And that's it. That's our only option. We can see a standard DIN 471. They're all the same. The strengths are the same. This is stainless, which is expensive, and we have not been told we need that. Black phosphate will give us a minor amount of corrosion resistance. Again, we haven't been told we can't use this. The next step up would be zinc plated. For us, I believe Shigley uses, I don't know if he defines it, we're going to use this. Let's use the black phosphate coated. About $1 US each, so it's not bad. Let's have a look at the detail. This tells us some useful stuff, including, oh nice, for the groove. That's what we want. Let's take a screenshot of that if I can get the right combo. It gives you sort of some advice here. It's not bad actually. Black phosphate finish is mildly corrosion resistant. PR is based on the shaft using harder material in the ring, which is probably okay for us. This is what we want to. I'm actually going to highlight this while we're at it. Diameter 1.6. say we still have to place it, so let's go ahead and change the step and download. It'll place it as a component. I'm just going to move it kind of into place. Keep in mind we're still got an analysis turned on. Don't ground it. It's not what we want. Just drag it. I'm going to do a joint here, J for joint. This is a circular face with a circular edge. Sorry, cylindrical face, circular edge. And you can tell that because it's giving you a center. Let's put it in its corresponding position. Right up against the hub. Looks good. And motion right now is rigid, that's fine. If you want to turn it so you can see what's going on, you can turn it 90 degrees if you wish. It's up to you. I'm actually going to turn it the other way. If I could snap correctly. Whoa. There we go. If we turn our analysis off, there's the ears. That groove is just a little big. Let's edit the sketch. Got a diameter in the copy paste right now. And what was this thing again? What was the width? Let's have a look. From my screenshot, we're here. Oh, 1.6. I'll just highlight that. And that's the width of the groove. So we need a dimension there. Oh. Finish the sketch. Now, what we would expect to see here is an overlap. The ring is modeled by McMaster-Carr as shipped, so in unsprung state. When you stretch it over the end of the shaft, you actually spring it around. It's gripping the shaft quite sturdy. For us, that's all fine. It'll just be overlapped a little bit in the model. That's okay. Like, we don't need to get too carried away with that. We've got sketches all over the place here. Which sketch is that? Where is that? Oh, here. Let's call this the Keyway profile. Keyway cut. Well, cut. Oh, sketch names are getting longer and longer. What did I call the other one? It's a keyseat. Sorry, keyseat, not keyway. Get these confused. There we go. So, kind of done, except for one small problem. This chamfer, sorry, is way too big. All right, the ring is barely covering it. Let's have a look at the analysis. Down here, it's not even in the right spot. This is not going to constrain it at all. So we need to make this chamfer smaller. Keep in mind, this is going to have an effect on this fillet, which will have an effect on the KT in this area. So we have to make this as big as we can, but we do need some axial placement. So let's right click on that, edit feature. We don't want to search for this. Let's make it say 1. See how that does for us. Can't really see through the part here, so we can hide the shaft. Like we could maybe, okay, let's have a look here. Okay, so it's inboard, that's fine. But at this end, it's covering it reasonably well here. We're not going to have a massive load on this, so let's go with 1. Unfortunately, our shaft now juts right into that. So can hide this guy, just see which where it is, edit that feature, go to say 0.8. We want save. Let's go for 0.8 for now. Again, if a machinist says no, then you can adjust, have 1 here and 1.2 chamfer. It's a little balancing act, but for us this is looking okay. So we've got it positioned correctly. We've got a keyway that's nicely hidden inside the shoulder, so this is quite good. You won't get junk in here from the backside. Our key is, I think, it looks okay. One last little discussion. If this was too high, like if the hub was too thin above the key, or mostly around this corner right in here, if we didn't have enough material here, or if we find out later we don't have enough material, we should have a look at the other standards. So this is the high type we used. Keep in mind that there is a low type where our original start to the keyway would be lower, further into the shaft, as per this. So we went for 68.85.1, but always keep in mind that there's a 68.85.2, which has a key deeper in the shaft, which I'd have less problems with, potentially anyway, less problems with the hub. This looks okay for me, and well, as far as I can see right now. We don't know the exact torque and all that stuff, so if the calculations came through and said this was not safe, we would, first step would be to go to a low version, or the other part of the standard. But for now, that's enough for this video, for sure. Next video, again, ignore my jumbled history here, all that sort of stuff. The next video will be how to convert this shaft end over to a bearing nut instead of a ring. But for now, thanks for watching, and over to you.